everybody, and welcome to today's episode of Math Masters with Mrs. Beaver, where we will be solving equations with variables on both sides. Would you please start to put your notes together? Your essential question for the day is, what is the process to solve equations with variables on both sides? So each day we just get a little bit more complex, and all is well. So if you got lost in 2.1, 2.2, 2.3, please make sure that you stop and ask questions and get some help. All right, so let's do a couple of examples. What is the process? Well, first thing you always do is you always show your work, and we always put this little line down the middle so we can stay organized, right? And I'm gonna look and see what I have on both sides. I have 5 x's on this side, and I have an x on this side. If that's true, pretend it's a teeter-totter, and if I have 5 x's over here and I have 1 x over here, is there something that I could take off of both sides? And you may say, well, yes, of course, you could take off 1 x. I could. So I'm going to take off 1 x from both sides. When I do that, look at the x's cancel out here, and over here, how many x's do I have left? You're right. I have 4 of them. 4x minus 1 equals, over here, all I have left are my 15. Then from there, now, hey, this is just a nice little two-step. I look around, and here's my -1 hanging on. How do I undo my -1? Got it. I add 1 to both sides, and when that happens, these cancel out. I drop my 4x down. Super, super important that you are showing your work. Because otherwise you will get lost and your signs will get you. One more step. Now what do I do? 4 x's equals 16. So that means x is 4. Ah, I love it. I do this for fun on the weekends. All right. Now, you go over and you do this one, and then push pause, come back to me, and look at, I made a typo. I'll fix that. This should be a plus sign right here. Let's make that into a plus sign, and then all will be well. Okay, ready? Go. And now we're back. I'm going to put this down. So I've got 4 p's on this side, 3 on this side. Well, is there a certain amount I could take off of both sides? Yeah, I could. I could take 3 p's off of both sides. Minus 3p. So when I do that, these cancel out. I drop down my -7. Over here, I've got 1p left, plus 2. How do I undo this piece right here? Yeah, I undo the plus 2. How do you undo plus 2? You subtract 2, and you drop down your 1p. Is it all right if you just keep it as 1p? Yeah, because that's what this was 1 as well, because that went to 1. So I've got 1p is a loss of 7, a loss of 2, a loss of 9. There we go. So these will be nice. I'm trying to think what would happen. I'm going to flip to another slide. Oh, look at what would happen if I have this. -2x plus 5 equals 15 minus 5x. Would you push pause for a second and figure out what you might do with that one, because it's slightly different. All right, on this one, I am not a big fan. Well, you've got a negative here and you've got a negative here. Is it okay to have that? You bet. I always like to try to get my x's positive, so I look right here. Here's my biggest minus, I guess, my biggest absolute value. So I'm going to add 5 to both sides. So 5x is here, 5x is here. So if they're negative, then you can just add them on instead of taking them off. If that happens, they simplify out here, drop down my 15. Do you see how I added? Be really careful with that. Over here, a -2x, a positive 5x gives me 3 x's plus 5. And now it's nice. Undo my positive 5, minus 5, minus 5. So I go in there and I get 10. And over here, I get 3x. Did I do it right? Oh my gosh, it doesn't look pretty. Yeah, not a big deal. So, how do I undo 3 times x? because yes, I am, right? It's okay. Divide by 3, divide by 3. And so my answer is just that 10/3 equals x. And you can leave it that way. IXL would probably make you turn that into 3 and 1/3. But for me, you can leave it as 10/3 and we're totally good. So that is where we will start. But what fun would it be if we just stopped there? Wait, there's more. Look at this one. This one has variables on both sides and all sorts of other things like distributive property and all sorts of good and fun and worthy things. So, draw the line down. If all else fails, at least draw a line. Then what do you think we should do first? Yep, I'm going to do this. I'm going to do my distributive property. We will use distributive property all the time. So if that's still tough for you, make sure that you ask questions. All right, so we got 6x plus 3 plus 2x. Over here, what do we have over here? 5x plus 12. All right, so the first thing I distributed if I need to. And then look over here. Is there anything that I could combine together? And the answer is, oh yes, there is. I've got a 6x, I've got a 2x. So I'm going to put those together. 6x's, 2x's together, I have 8x's plus 3 equals 5x plus 12. All right, pause it, go through, quick figure the rest of that out, and I'll go through too. I'm going to move the 5x's over here, minus 5x. So I got 3x plus 3, drop down my 12. Ah, this is so fun. Minus 3, minus 3. So I drop down 3x equals 9. Am I done? Oh no. There we go. We call these multi-steps. There's lots of steps going on. And x is 3. Then you look and see, could that even be possible? Well, 2 times 3 is 6, 7. So 21 plus 6. That makes 27 over on this side. And then 15 plus 12 is 27 over on this side. Oh yes, I got it. So we're going to write down a couple of things, then I'll have you do a couple of examples on your own. This says, record the following steps in your notebook. So yes, record them in your notebook. We'll refer back and forth to them a whole bunch. So step 1, always distribute if necessary. After you have distributed, then we go to step 2. Again, just pause. Combine like terms on the same side if necessary. We did that last time. Step 3, move your variables to the same side using inverse operations. So you get all the variables to one side. And after that, we're going to get all of our constants to the other side using inverse operations. And very last, we will solve for our variable. So we're going to come back to this a ton, and we will spend more than one day on this. Pause it if you need to. We're going to do one more example, and then I'll stop for today. Here it is. Example number 2. 19x plus 8 minus 8x equals 4 times the quantity 5x plus 2 plus 6. So you pause it, and then we'll come back. All right, super sneaky. I'm going to move the spyglass. My answer is x equals -4. Did you get x equals -4? If not, pause again, try to figure it out. I'm going to put my steps on here, but you see if you can find your error if you did not get x equals -4. All right, so that's all of my steps. I moved these two together. I combined like terms, negative sign, so you get 11x's. This I distributed. Then I combined some more like terms, kept solving, divided by 9, got -4. So I'm going to stop on this video for there because that's a lot of information, and that many problems is probably plenty, and we'll practice some when we get to class. See ya!